what I'm going to do is a couple of things. First, we've got about 15 minutes, so it'll be very brief. First, we recently started something called a School of Sustainability at IIT Madras. So I'm just going to spend a minute telling all of you what that's about, so that in future, if you feel that there might be any relevance or anything that we can help out on, at least you know that we exist. And secondly, by way of case studies, my background is in civil engineering. And so we look at the circularity of what we call the built environment. So buildings like this, which lead to a lot of carbon emissions. So as you might already be aware, and I'm sure this was probably discussed this morning, we build a lot. And there are scary estimates that say that India has only built 30% of what it needs to build, 2/3 of what we need to build still needs to be built, and things like that. And the most common building material that we use is concrete. It's the most common building material for a variety of reasons. It has excellent structural properties. It's quite durable. Something that you built with concrete can last for 50, 60 years. It's actually quite affordable. So a lot of people can afford things built out of concrete, not necessarily out of other materials. So the material is not going away. But unfortunately, it emits a lot of carbon into the atmosphere, right? So you've got to decide how you want to deal with this problem. Do you want to stop building? And that doesn't really seem to be an option, because we seem to have a lot of housing and infrastructure to build. If you build, can you build with other building materials? And that also doesn't seem to be an option that's scalable. Yes, there are several prototypes, etc. And if I wanted to build one small house, I could do it. But if you look at this data, the data on the Pradhan Mantri Awas Yojana and the number of houses we need to build, I don't think alternative building materials are going to get us there, which means somehow we have to build. We have to build with materials like concrete, and we'll have to figure out how to do that without destroying the environment, right? And so that's, it's what I want to sort of talk a little bit about. Great. So this is up. How do I move it around? I'll just ask you to move it around. Okay. So this is our School of Sustainability. Just very quickly, we wanted to be sort of a go-to place for policy and research on sustainability. We want to do three things. We are IIT Madras. We are an educational institution, so teaching is important. It's an important part of our portfolio. So we want to teach sustainability in interesting ways, not just for students of IIT Madras, but also to people who are outside of IIT Madras. I'll talk about that in a second. The thing with sustainability is sustainability ends up being very multidisciplinary or interdisciplinary, depending on how you look at it. And while we talk a lot about interdisciplinary work, it doesn't really happen that much, because particularly in academic institutions and in companies, you have these silos that form, and it's very difficult for people to collaborate across boundaries. But that's something that we hope to enable. At IIT Madras, we have 18 different departments today. We have about 200 people spread across these departments, all looking at sustainability in some way, shape, or form. And the idea for the school is to bring them together, so you can have civil engineers and mechanical engineers and economists all coming together to understand how we can build sustainable low-cost housing, right? So the civil engineer can figure out the material side of things. The mechanical engineer needs to figure out the air quality and cooling side of things. Everyone knows temperatures are going up, right? Cooling is going to be an enormous issue that we have to solve. And economists need to come and help us figure out how we can do this on an affordable basis, right? So we want these kinds of partnerships to form. And finally, we also want to make an impact through policy. Okay, can we move to the next slide? Okay, I don't have too much time, so I'm not going to go into all of these. But the point is, we have a series of teaching offerings that are coming out of IIT Madras. Some of these, like this minor in sustainability and this IDDD program, which is just a fancy word for a master's program, are typically for students within IIT. But we're also looking at coming up with 6-month professional certification kind of programs, which anybody could take. You could be at another university, you could be working in a company, you could be part of government. But the idea is to upskill you on at least certain aspects of sustainability that at IIT Madras we might know something about, right? So particularly on the environmental side of sustainability, right? So those will come out later this year, will be open for anyone to take. We might also have some in-person schools that we have. Next slide. And this is just a very complicated slide to convince all of you that we are doing some work. It'll take me about half an hour to go through this, so I'm not. But essentially, there are 4 boxes that I want to point out. There's a box on the top right called scenario modeling. And that's something that we like to do at IIT. We like to build all kinds of models that tells us what the future might be like, right? What Chennai will look like a little 25 years down the line, what the cement industry will look like 25 years down the line, what the atmosphere will look like 25 years down the line, so that we can decide today what we may do to push ourselves towards more sustainable futures. So that's one thrust area. Bottom right, you see something that says decarbonization. So that's another thrust area where we have a lot of researchers working on how do we reduce the carbon footprint of what we do. And that's people working on electric vehicles, on hydrogen, on carbon capture, on sustainable construction materials, all kinds of things there. On the bottom left, there's something that says human settlements, which is a group of people working on how we can take campuses or villages or towns or areas, regions, and make them completely circular. So how can we ensure that they are completely sort of water balanced, waste balanced, right? So essentially everything that they need sort of keeps regenerating within that same sort of environment. So we have researchers who work in water, in waste, in mobility, transportation, etc., all coming together to try to figure that out. And the one at the top, which actually I think is really more in the strike zone of a Madras School of Economics than an IIT, but which we want to really look at, is this thing about behavioral and business model change. Because at IIT, we have lots of technological innovations. Many of them have been proven to bring down carbon footprints and be more sustainable, but very few of them are actually being used in practice, right? So the technology alone is not going to save us unless individual behavior, business models in companies and government policy all move in step. So we want to sort of see how we can bridge that gap as well, right? And there are a number of projects, and there is that circularity thing there, which is more relevant to what we're talking about here, right? So that's just a quick glimpse of the school and what we do. Let me get quickly to the case that I wanted to present, although it's not quite a case. Can I go to the next slide, please? Okay, so I talked a little bit about how we do models. So one of the kind of models that we developed some time ago was to look at how the city of Chennai has been growing in the past and what it might look like in the future. Just assuming, the past trends continue. So many of you have probably seen these maps. 1970, there are lots of water bodies. 1980, 1990, and this is, there are maps of 2020 or 2017, I don't know what the latest one is, where you see very relatively little blue, lot of red, right? So we looked at all these trends, used some modeling techniques, I won't get into them in detail, to try to look at what Chennai would look like in 2025. And this is what Chennai is likely to look at in 2025. As you can see, lot of red, right, happening in Chennai, lot of built up area. So then the question that we asked is, if Chennai is going to look like this in 2025, then so many new buildings are going to be built, right? And we see that all around us. If so many new buildings need to be built, and we can estimate how many new buildings need to be built, how much carbon will we emit because of the construction of these buildings and because of the energy that is used in operating these buildings? So we go to the next slide. Okay, so we emit carbon in two ways, right? One is when I build a building, I need cement. Okay, now the problem with cement is, if you go into the chemistry of cement, you have to emit CO2 in order to produce cement. It's a chemical reaction. If you want that grayish thing in your hands, you have to emit carbon dioxide, right? It's just the chemical nature of it. So every time I build something, I have to emit some carbon dioxide to build it. We call that embodied energy. But then after I build it, right, this auditorium is built. Okay, and this auditorium is going to be operated for, say, 50 years. And for 50 years, we're going to be running lights and fans and all of these. And all of these draw electricity at the moment primarily from coal-fired power plants, which are also emitting carbon dioxide, right? Which means there is what we call an operational energy component, right? So about 25% of a building's life cycle energy is what we would call embodied during construction. And about 75% is, or actually it's more 1/3, 2/3, something like that is operational. So now if you look at the volume that you're going to build and the amount of the buildings, and the amount of emissions that you will have, if I go to the next slide, right? We came up with these graphs. Again, this is very colorful. You're not going to be able to read anything from this. But we came up with some estimates on how much carbon will Chennai emit in the next 5 to 10 years. And roughly the estimates were something like 220 million tons of carbon dioxide is going to be emitted, right, in the next decade or so, purely within Chennai, purely because of the construction that we're going to do. right? And this is the construction that you see all over, right? I don't know, go from here to Anna Nagar, you'll see all kinds of construction that's happening. So now the question, so this is the case, right? This is the data. Now the question that we have to ask ourselves is, what could we possibly do about it? 220 million tons seems a large amount, right? I mean, that's a lot to put up there, right? What do I do to reduce this? Okay, so I'm going to pause for a second and see if you guys have any answers, right? What could I do, in your opinion, to reduce the 220 million tons of carbon dioxide that I would put in the atmosphere? Well, if I did it, it would be a sustainable building. But what would I do to make it a sustainable building? Yeah, sorry, you had a point you're going to make? No? No. Yeah, sorry.
I mean, you could tax the builders.
So I could tax the builder.
Carbon there, everything.
Right, so I could tax the builder. Now, one of two things will happen. One is the builder will pay the tax, hike the price of the building. The carbon emitted will still be the same. The other is maybe people will build less because of that, right? Now, so essentially one of the things you're saying is figure out a way to build less. And that's the best solution. The best solution to stop emitting carbon is to not to build at all, right? Certain things are necessary. So yes, we have a lot of hutments and so on. You want to build, take kacha houses, make them into pakka houses, we have to build. But does everyone need their third luxury resort on the beach? Maybe not, right? So yeah, so that's one thing, is not build. And it's a great solution, but practically it's very difficult. You know, people essentially say, it's my money, why can't I build? Okay, what else could we do other than not build? But it is a fantastic solution.
You can offset it by growing.
Okay, so that's again one thing you can do. You can say, I've emitted the carbon there, let me do something else. It's okay. It's also a good idea. It's perfectly fine. I am not convinced. Yeah, so this is a kind of carbon capture, right? It's natural afforestation. It's just one of those things where you say, you allow me to do bad, but then, you know, if I do something good, it compensates for me doing bad. So that's fine. I mean, that's also okay. I put carbon in here, I reduce it there. But are there other more elegant solutions? Both of these are perfectly acceptable solutions. They're also part of the list that I had. Okay, what else could you do? Okay, I could keep going on. I mean, normally when I teach a class, I go on, but now I have only 15 minutes, out of which I've exhausted about 14 minutes and 30 seconds. So I'll have to wind up quickly. But other things that we would need to think about is, first, how do we design these buildings? Okay, so can we design them with as much, say, natural ventilation and stuff like that as possible? So look, we live in Chennai. We keep complaining that Chennai is one of the hottest places on the planet, right? So, so therefore there must be a lot of sunlight for Chennai to be really hot. This is what, 2:30 in the afternoon now, where the sun is more or less at its peak. Okay, we are in a hot place with a lot of sunlight. The sun is at its peak, yet we have all the lights on in this auditorium. Okay, that doesn't seem to be a very sensible way of designing things to me, right? So how can we sort of get to a point where we design this, for instance, in such a way that I don't need those lights, I reduce the energy that I require, right? Do I really need, there are, as a civil engineer, I see beams and columns and slabs everywhere. Do I really need beams and columns and slabs as thick as they are here, right? Literally most buildings like this are actually designed so that if an elephant walked on that top gallery, the thing would not fall down, right? That's the level of rigor at which we design it. What are the chances you're actually going to have an elephant walk there? Right? None. Right? So could we compromise a little bit on that, by virtue of which our members are a little bit thinner, right? And there's many strategies to it. I'm simplifying it grossly, naturally. So that I actually use less carbon dioxide in the first place. I use less cement in the first place. So I don't not build, but I build less, right? But a third sort of, so there's strategies on the design. But there are also important strategies that we have to look at from the materials perspective, right? Which is, we demolish all of these buildings. What do we do? Every time I build a new building, I get fresh material, right? I get fresh cement. I break down a mountain and I get this jelly, right? Everyone sees this. Everything's fresh, okay? So what happens when the building finishes its life, right? To what extent can I reuse parts of that building, right? And that's where the circularity comes in. Certain things are being reused. So whenever this building comes down, some fellow will come and strip all the doors and windows because those can be reused, right? But there are lots of other things that can be reused as well, which at the moment do not get reused, right? So that's another big strategy for reducing the amount of carbon that we emit. And then, of course, there is putting solar panels, etc. So even if you want to put the lights and fans on, you're not burning coal, you're burning solar. But because the theme of this is circularity, and because we're doing this in the Madras School of Economics, I wanted to leave you with one thing. We build a lot, we are demolishing a lot today. Today, there's really no greenfield development, right? A lot of development is take down an existing building, build something new, right? So we have a lot of what we call construction and demolition waste, right? That somehow we need to reuse. It is building material, right? So why can't we reuse? At IIT, we've got enough experiments that we've done. We've crushed them, we've put them into this, we've tested them, and we've sort of shown how some of them can be used as building materials. But the reason it hasn't taken off yet is because the economics just don't work out. At the moment, the cost of recycled material for buildings is greater than the cost of virgin material. So I'm a builder, I'm concerned about profitability. Simple, I'm going to go for the cheaper stuff, which is the newer stuff, right? So the question and the challenge to people here, I mean, I'm assuming many of you are from Madras School of Economics, maybe you're not, but the challenge here is, what do we do from a market perspective and a policy perspective to flip that switch so that it becomes cheaper to use recycled material, and therefore it incentivizes people to build buildings in a more circular fashion, right? And thereby saving the environment, but also perhaps making a higher profit. I mean, we have some of the answers in terms of what needs to be done. Partly the costs are high because you don't know where to find these materials. So by the time you transport here, there, etc., it costs a lot more than just going to the local cement shop and buying. So there are some supply chain issues. I mean, we've done a lot of work on this to break this down, but that to me is the challenge. So if we can solve that economic challenge, we can bring in circularity so that graphs like this, I mean, look at that, 2,500 million tons, etc., all of that can sort of disappear. Okay. So, so with that, thank you very much for your attention.